Hi guys, welcome back to YouTube channel Chemistry Live UGPG. So today we'll be talking about resonance or mesomeric effects. So this is in accordance with NEP syllabus. So I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime, and help to learn others. So let's talk about resonance or mesomeric effect. So first talk about what is resonance. If we can write one molecule in more than one structure by redistributing their electrons, but none of the structures are able to explain all the properties of the molecule, then such structures are known as resonating or canonical structures, and this phenomenon is known as resonance. So what is happening here? If we write one molecule in more than one structure by redistributing their electrons, but none of the structures are able to explain all the properties of the molecule, then such structures are known as resonating or canonical structures, and this phenomenon is known as resonance. So as you can see here, the example, the benzene. So here we have pi bond and pi bond. So now they will undergo redistribution of their pi electrons. So you end up with this structure. And this is the structure of resonance hybrid. Similarly, this ester. So this lone pair will come here and this double bond will come here. So you have a resonating structure like this. So the actual structure will be the resonance hybrid of all the structures. So the stability of the molecule depend upon the delocalization of electron. So higher stability means there should be resonance. So higher the delocalization of electrons, so greater is the stability of the molecule, and hence higher is the resonance energy. For example, this is the resonating structures for phenol. So oxygen lone pair will come here and this pi bond will break here. So you end up with this structure. Again this minus will come here and this double bond will break here. So again you have this structure. So similarly you end up with this structure. So these are the different resonating structures of the phenol. Then let's talk about what is the mesomeric effect. So the creation of a polarity in organic molecule by transfer of pi electrons in a conjugated system due to resonance or delocalization of electron is known as mesomeric effect, or that is called M effect, or resonance effect, that is called R effect. So if you can create the polarity in an organic molecule by transfer of pi electrons in a conjugated system due to resonance or delocalization of a electron, then that is called mesomeric effect or M effect. So for example, plus R or plus M effect. So when groups having lone pair of electron will donate electrons to the double bond through resonance, then it is called plus R or plus M effect. So for example, aniline. So here you can see this lone pair will be donated here and this pi bond will break here. So you will have so many resonating structures as you can see here. So the decreasing order for plus M effect of the groups as follows. So O minus greater than NH2 greater than OH greater than OR greater than X, etc. Similarly we have also minus R or minus M effect. So when groups can withdraw electrons from a conjugated pi bond through resonance, it is called minus R or minus M effect. So suppose we have this system cyanide. So electron withdrawing group and it is conjugated to a double bond. So here the electrons will be withdrawn towards the cyanide. So you can have a conjugated structure like this. So the order of minus M effect as follows. So NO2 greater than Cn greater than SO3H greater than CHO greater than carbonyl. Then let's talk about the application of mesomeric effect. So the dipole, for first example is dipole moment. So dipole moment can increase or decrease due to the M effect. So suppose for example ethyl chloride. So dipole moment is 2.05. So here you have plus I effect of methyl and minus I effect of chlorine. So they are in the same direction. But if you take the vinyl chloride, so here you have a minus I effect of a chlorine and plus M effect of chlorine. They are in opposite direction. So inductive effect operates in this direction, and delocalization occurs in the opposite direction. So dipole moment is 1.4 d 45 dB. So that is low. So due to the both inductive and mesomeric effect, they operate in the opposite direction. Similarly, nitrobenzene. So dipole moment is 4.22 dB. But if you take paranitro-aniline, so it has a high value 4.92 dB. So here minus I effect and plus M effect are in the same direction. So that's why they have a high value. So please subscribe to our channel Chemistry Live UGPG so that you can get updates. So for class 11th and 12th, this is the channel Foundation Chemistry AB. So this is a simple step towards e-learning, making life better. Thank you all for learning.